What's up, geometry scholars? We're going to take a look at some of the questions that you can anticipate on the next quiz. And I can see that we're going to need to find the length indicated. And for question number 1, that's going to be RQ, this segment right here. So how are we going to go about doing that? Well, I know that segment SR plus segment RQ equals this entire length, which we can describe as SQ or 23. And we know that because of the segment addition postulate, which is like a little bit of like a small segment plus the other small segment equals the whole segment of the big segment. All right, let's set this up into an equation because we're going to need to solve for x. Let's go ahead and do that. And I know that's going to be 7x minus 2 plus the other small segment, which is -1 plus 6x equals 23. All right, and we're going to need to combine like terms, and I know that we've got 7x and we've got 6x, and that's going to give us 13x when we add them together. And I can see that we've also got what? We've got a -2 and we've got a -1, and that's going to give us -3 equals 23. Well, we want to isolate x, right? And so to do that, what we're going to do is we're going to add 3 to both sides, and then it's going to give us 13x equals 26. And of course, we want to isolate the x, so we're going to divide both sides by 13. And so x, of course, is equal to, when we divide 26 by 13, 2. All right, but we are not done yet. What we're going to need to do is we're going to need to substitute this value back into RQ. So let's go ahead and do that right now. And what do I know? I know that when I write -1 plus 6, open parentheses 2, that's going to give us what? Well, -1 plus 12 equals what? That's going to equal 11. 11, ladies and gentlemen, is the correct answer. 11 is the length of RQ. Let's take a look at question number 2. Here we've got angle IJK, which is this whole angle, and I'm going to represent this angle as 13x plus 3. What else do we know? We know that angle BJK is equal to 120 degrees. So let's mark up the diagram and indicate that right here. Beautiful. And then what else do we know? We know that angle IJB is equal to 2x plus 4. So let's indicate that right here. 2x plus 4. All right, so we're going to apply the angle addition postulate, and we remember that the sum of these two angles, right, this green angle and the red angle, equal the entire angle. This, we'll call it this blue angle. Let's set up the equation, and let's figure out what the value of x is. So we know that it's going to be 2x plus 4 plus 120 equals to 13x plus 3. Great, so let's combine like terms, and so we're going to have, can't combine 2x with anything on the left side just yet, but we can add 4 to 120, and that's going to give us 124 is equal to 13x plus 3. Beautiful. Let's subtract 2x from the left side, and if we do it to one side, we got to do it to the right side. And so that's going to give us 124 equals to 11x plus 3. And then what do we know? We're going to subtract 3 from both sides, and that's going to give us 121 equals 11x. And we need to isolate x, and so let's divide both sides by 11. And when we do, we know that x equals 11. Great, but that's not what we're trying to figure out. We're trying to figure out the angle measure of IJB. So what we're going to do is we're going to substitute the value of x, which is 11, into 2x plus 4. So let's do that right here. So 2, open parentheses, plus 4, and we're going to substitute in that 11. So 2 times 11 is 22, plus 4 equals 26. All right, we just did it. We just figured out the angle measure. We just figured out the answer, 26. Great. Question 3, find the midpoint of the line segment with the given endpoints. And we remember that if we have like a line segment, for example, let's say right here, we remember that the midpoint is like smack dab in the middle. And so that's our objective. That's what we're trying to figure out, in this case, in the form of a coordinate. The first thing that I like to do is I like to label these coordinates. So we've got x1, y1, and we've got x2 and y2. Beautiful. And I'm going to set up the midpoint formula like so. And this is typically how I like to do it, just so I can stay focused and I don't lose lose track of what it is I'm trying to do. So I know I'm going to put an x here and an x here. I know I'm going to put a y here and a y here. And so let's just jump on in and do that. And so x is 5. I'm going to put a 5 and a -5 for x1 and x2. And then we're going to do a -8 and a +4. Beautiful. And so we're going to simplify. And so I know that 5 plus -5 is 0. And so that's going to be simplified to 0 over 2. And then -8 plus 4 is going to give us -4 over 2. And so we need to simplify this further. And so I know that anything divided, or 0 divided by anything is 0. And so this simplifies to 0. And then -4 divided by 2 is going to be -2. And there you have it. This is the answer. This is the midpoint. Question number 4. It asks us to find the other endpoint of the line segment with the given endpoint and midpoint. So here we've got an endpoint, -8, 6, and then we've got the midpoint, it's the middle of the segment, 4, -2. And I sort of plotted it right here, right? And so what does that mean? If this is one end, right, and this is the middle, then the other end is going to be approximately right here, right? And so my assumption is if we just sort of extend this line, it's going to end up like right around here, and that's going to be like what? Like, I don't know, 15, it's going to be maybe 14, 15, 16, and then down like around -9, -10. So it's going to be approximately in this area. Let's figure out precisely where it is by applying the midpoint formula. All right. So like in question number 3, I like to set it up this way so I don't get confused, so I stay focused, so I know where everything is supposed to go. And I know in this case, unlike in the previous example, we've got the midpoint, which is 4, -2. Great. And what else do we know? We know the endpoint. We know one endpoint. We've got an x value and we've got a y value, but we don't have the other x value or the other y value. So we're going to label this -8, and we're going to label this 6. And we don't have that other x value, so we're going to call it simply x. You could do x2, but x works as well. Likewise for y. And we're going to need to isolate those variables to, again, figure out the other endpoint of this line segment. So let's go ahead and do that. And I know that this segment right here, or this component, refers to this x value. And here we go. This component involves the y value. So let's set this equal to one another, and then we're going to isolate for x, and then we're going to isolate for y. Great. All right, so we've got -8 plus x over 2 equals 4. And we're just simply going to start there. We're going to figure out what the x value is. We're going to need to multiply both sides by 2. And when we do, the 2's cancel out. And we've got -8 plus x equals 8. All right, that's great. We're going to need to add 8 to both sides. And that gives us x equals 16. All right, and you know what? That's what we said. Like, we made a prediction. It was around 14, 15, 16. The x value is 16. Great. Now we're going to do the same thing for the y values. Let's set this up. So we've got 6 plus y over 2 equals negative 2. Okay. Let's multiply both sides by 2, because again, we need to isolate the variable, we need to isolate the y, and the left side cancels out. So we're left with 6 plus y equals negative 4. All right, and we're going to want to subtract 6 from one side, and if we do it to one side, we got to do it to the other. And so y equals negative 10. Whoa, all right, and so let's take a look at this. We just figured out what the other endpoint is, and the other endpoint is 16 comma negative 10, which is about right there. That, ladies and gentlemen, is our answer. Question number 5, find the distance between each pair of points. And so here are the coordinates. We can approach this problem in a few ways. We can apply the distance formula, or we can apply the Pythagorean theorem, and that's what I'm going to do right now. So here is what I know. I'm going to first plot negative 4 comma 0, which we know is, it's about right there. And 2 comma negative 5 is going to be right here. Beautiful. Okay. And so I'm going to zoom in on this coordinate plane, and we recall that if we set up a right triangle like so, and we recognize that right here, of course, we have a 90-degree angle. If we apply the Pythagorean theorem, we know that it's a squared plus b squared equals c squared. We don't know what this length is, right? That's our objective. Like, that's what the problem is stating, and we need to figure that out right now. But what do we know? We do know the length of A, and we do know the length of B. And so the length of A is what? It's 6, right? And the length of B is 5. Okay, great. So let's figure that out right now. So we're going to apply the Pythagorean theorem, and I'm going to rewrite that. A squared plus b squared equals c squared. And for A, we're going to plug in 6. And for B, we're going to plug in 5. Great. And we're going to need to figure out what C is. All right. 6 squared, of course, is 36. 5 squared is 25, and this is equal to C squared. 36 plus 25 is 61, equal to C squared. But you know what? We need to isolate C, and so we're going to take the square root of one side, and we're going to have to take it to the other. And so C equals radical 61. That is our answer. That's the length from this point to this point.